Okay, so hi guys. So today I want to discuss this the solution of this problem, rotate list, which appeared on 11th of March 2022 as a part of the LeetCode daily challenge. It's a question on linked list, obviously. So let's get right into it. So like the problem statement is very straightforward. Like you are given the head of a linked list, and you have to rotate the list to the right by k places. So let's see the first example. Okay, so like let me write it down. We have a list which goes like this: 1 2 3 4 5, right? Yeah, and then we are given k equals to 2, right? So basically we have to rotate the linked list to the right by k places. That's what it is. So let's say I first that means we have to take 2 turns to rotate the linked list. That's it. So let's say we are at the first turn. Okay, so every each and every node will be the shifted by to the right by 1 place in each turn. So it will turn out something like this: 5 1 2 3 4, right? And then there's a second turn. Ultimately the linked list will look something like this, and this is our answer: 5 no 4 4 5 1 2 3. That's it. That's our answer. So basically what we did is we shifted each node by uh, by 2 places, right? If I consider the index of consider the index to be 0 indexed: 0 1 2 3 4, right? So the element at 0 will get shifted to the index 2. Similarly, the index at element at index 1 will get shifted to the index 3, that is 1 plus 2 equals to 3. Similarly, element at index 4, I'm sorry, 2 will get shifted to the index 4. Element at index 3, this is one particular case, that because let's say consider element at index 3, right? So the new index of this element should technically be 3 plus 2 equals to 5. But we know that there can be at most like the index can at most go up to 4. So basically this we have to take this uh, modulo the number of nodes in this linked list, that is n. That is basically in this case 1 2 3 4 5, it is 5, which will come out to be 0. That means basically it will come out, it will appear at the beginning of the linked list. That's it. We have to shift these elements in a circular manner. So once if we see that if an element is crossing the last index, then we have to take its mod with the size of the linked list. That's it. Like also consider this element at index 4. The new index should be 4 plus 2 mod 5, that is 6 mod 5 equals to 1. That's it. Cool. Now this k factor, we have been given that k can range from 0 to 2 to the power 2 into 10 to the power 9. Now this k might also be greater than n, right? Now let's consider the case when k is equals to n. Okay, consider k equals to n. Let's consider this linked list 1 and 2. Okay, so n here is 2, and let's say k is also 2. So in first turn the linked list will turn out to be like this, and second turn linked list will turn out to be basically 1 2. So what we see is the final linked list and the linked list we started with are the same. Why? Because we are shifting the linked list by two places, and by two places we mean that we will get the same linked list back because the number of nodes in this linked list is 2 itself. So here's a really good point that let's say k is greater than n. So we want to get k mod n. Why? Because let's say if k is greater than n, let's say k can be represented as m into n plus r. Okay, so if this is a case, then m into n, this much we can rotate the linked list and we will still get the same linked list back. Okay, so like in this case, like if n was 2 and k is 2, we get the same linked list back. Similarly, if n was 2 and k was 4, we will still get the same linked list back because after shifting by two places, again we shift the linked list by two places and then we still get the same linked list back. So basically we want to take the mod of k, okay, mod of k mod n. Basically you want to check the remaining turns that we are left with, that we want to shift the nodes with, shift the nodes to the right. Okay, so let's say we had k equals to 3 in this case. In this particular example, I'm continuing with this example still. K equals to 3, so 1 2. Okay, so first turn the node linked list will look something like this. Second turn the linked list will look something like this, which is same as the linked list we started with. Third turn we will get 2 to the power I mean 2 and 1, right? Now what we see is the linked list at second, at third and first turn are the same. Why? Because 3 is basically can be represented as 2 into 1 plus 1. Basically 3 mod 2 is 1. That means we can you know shift the linked list totally by one turn for one time, and then we will be left with one extra turn, right? So if and shifting up the whole linked list by the number of by the total number of elements will give us the same linked list back. So after completing this, we are going to be left with the same linked list, and then we are going to be left with some turns. In this case it is 1, and then we have to check it, right? So ultimately we can be rest assured that ultimately k mod n will obviously range from uh, 0 to n, where n is exclusive. Okay, now how to solve this problem? Now one very simple solution 1, let's call it. We can first of all store the elements in some kind of an array or vector. Let's say I'm taking a vector int v, and we have to get the length of the linked list. Okay, so if we want to get not really, we don't really need to get the length of the linked list. We can just traverse to the linked list. We can we have a vector, and just I have a list node. I have a pointer, current pointer, which is initialized to head, and while car is, I mean the current pointer is not null, we push back in our vector the value of the car pointer, and then we proceed to the next element. That's what we do. And by the time this loop ends, we will have all the elements in the form of a vector, right? And why do we want to create a vector out of these elements? Because we can access the indexes, and if we can access the indexes, then we can just create another vector. Let's say vector int v1, which will, let's say, is initialized to v. Okay, and of course we have taken k mod n for the reason that I discussed above. You can go check that out, if that's not clear. Now basically for we iterate over all the elements in the vector v, and basically what we do is we do I plus k mod n equals to v of I. That's what we do. And this is O of n solution. This time complexity is all right. It's not really O of n square or something like that. The time complexity is fine, but it will take O of n space too, right? Because we are creating a vector, and then of course, yeah, that's what we're doing. And also the task is not done yet. We have the new vector, but we also have to create a new linked list, right? So I can have two new pointers. Let's say h, that is the head of our new linked list that we will form. Let's initialize it with null, and let's say a previous pointer that will represent the previous node, that like the last node of the linked list so formed so far. Okay, so and we also initialize with null, and we basically we can traverse to the linked list, I mean the new vector. Basically we want to create a new node with the value being v1i, right? So let's create a new node, and it will be its value is going to be v1i. Okay, now we want to join this node to the linked list that we are forming, the new linked list that we are forming. Now if we see that if previous is null, that means this particular value is going to be the first element in our new linked list, right? So we can put up a condition, right? If prev is equals to null, that means this is the first node of our new linked list that we are going to form. So what we can do is we can initialize head to be this node, because I mean not head, the new head will be called h, so we can do this. And if it's not the case, then we have to join this new node to the linked list that we have formed so far. So for that we have to do prev next equals to node. Now ultimately this and after this particular node is the last element of the linked list we have formed so far. So we have to change the pointer prev to point to this current node, and ultimately we can just return prev. I'm sorry, return h, and let's dry run it. Okay, let's just take that example. Okay, so we have the after like we have k equals to 2, and we then take k first. Initially we calculate the length of the linked list, which we can do by simply traversing the linked list and keeping a keeping an variable in, and we can and every time we come across a node, we can just increment a by 1. Okay, that we can do. So let's say we have n, which is in this case will come out to be 5, and then of course as per our code we will perform k mod n, which will still come out to be 2, because obviously k is less than the number of elements, total number of elements 5, so it will come out to be 2. Now what we do is create a new vector v, and as per our code the new vector with the vector v will come out to be 1 2 3 4 5, simple as that. So let's mark the indexes. Okay, now what we do is traverse to the element, traverse through the vector v, and we also create a new vector v1, and in this particular for every I in v, what we do is v1 I plus k mod n equals to vi. Basically we shift the particular ith element to the right. And of course, if it crosses the last index, then we have to obviously bring that element to the first. So that's why we take the mod here, because we have to rearrange the elements in a circular fashion. So yeah, that's that. And after doing that, we will obviously get, if let's just write on the code. So if I shift 1 to this particular 0th element, two places to the right, obviously we will 0 plus 2, we will then the new index will come out to be 2. So if we have the indexes as follows in this new vector, here we will get 1, and then similarly we will get 3, then 4, and after 5 and the index at the third element, it will come out to be, the new index will come out to be 0, and for the index 4 element, it will come out to be 1. So our v1 vector will go like this. Okay, now we will just form the linked list. As I mentioned, we have h where pointer, which is initialized to null, and also prev, which is initialized to null. So, and then we traverse through each of these elements. Okay, now let's see. Let's consider the 0th element. 0th element. So we create a new node that is whose value will be 4. Okay, now I see that head or previous is null. That means this is the first element in our newly formed linked list that we are going to form. So what we do is we basically make h point to this node, and then what we do is make prev also point to this node. Okay, so this is our newly formed linked list so far. And then we come to index 1, and we see that the element is 5, so we form a new node obviously. And of course, we had a linked list formed so far. H is pointing to 4, and also prev is pointing to 4, and then we see that prev is no longer null. That means there have been other elements in the linked list, and prev is pointing to the last element in the newly formed linked list. So what we need to do is create a link between prev and this newly formed node. That's what we do. So we have to create this node, that's using as per the code, like prev next of prev will be equal to the new node. Okay, and then we will have to make prev point to this node. As simple as that. Now let's consider the second iteration. Iteration at the index 2. So we have 4, 5 formed so far. H is pointing to 4, prev is pointing to 5, and the new element is 1. Okay, so I have 1, and now we have to create the link and then make prev point to this 3, index 3. Similarly, prev is pointing to 1, h is pointing to 4, and then the element is 2, so we have to create the link and then make prev point to 2. And ultimately, index 4, we have the linked list formed so far like this. And the last element, which is 3, we have to create the link and then make prev to be equal to 3, and the loop ends because this 4 is the last index, and ultimately we have this new linked list which is a required answer, and we can just return h. Okay, so this is one solution, but the problem with this solution is time complexity is good because it is O of n solution, but space is also of n. So we have to ask ourselves at this point, can we do better? Now generally, like in linked list, we can maybe do better because basically what we're essentially doing in this question is we are just changing the relative links in these nodes, right? We are not actually creating new values or something like that. So we can try to think of O of 1 solution, because changing the links in a linked list is obviously O of 1, constant space operation and constant time operation. So yeah, let's Think about that. Solution 2. Okay, now I would like to take that example again. 1 2 3 4 and 5. Okay, let's mark these indexes. Now one thing that I will still need to do is for this solution is calculate the length of the linked list. That is going to stay constant. So let's say I calculate the length of the linked list, and that comes out to be 5 in this case. Okay, now ultimately what is our new linked list going to look like, right? So obviously, as per I discussed above also, so the new linked list will be looking like this, right? 0 1 2 3 4. So basically we can essentially divide this linked list into two halves. Let's partition this linked list along this link. Okay, so what is the difference between these two halves? You see that like every element in this left half is going to be shifted to the right half. Why? Because like I mean basically each of these elements in the left half are just going to be shifted, not really shifted and brought back to the beginning of the linked list. If we see that like for the 0th element, 0 plus 2 will come out to be 2. That means we don't have to really shift to in a clockwise, in a circular fashion. So 0 plus 2 will come out to be 2. 1 plus 2 will come out to be 3, and 3 plus 2 plus 2 is will come out to be 4, and all these are fine because we don't really have to do the mod operation, because these are going to be just shifted to the last to the right. We don't really have to bring this to the front. But the problem with the right half elements is, like, let's consider the third element, 3 plus 2 equals to 5, which is obviously greater than the index of the the last element. So we have to take mod with 5, and it will be coming out as 4, I mean 0, and similarly with 4 it will be coming out as 1. So basically what we see is the relative ordering of the elements in between in the left hub and the right hub are the same, because like see 0, the left hub is given as 1 2 3, and this is the relative ordering is going to stay the same. Let's check the first, I mean the linked list that we are given with and the linked list that we are going to form. The relative ordering of the elements in the left hub is the same, right? 1 appears before 2, 2 appears before 3, and same in the newly formed linked list. And same with the right hub elements. 4 appears before 5 in the beginning linked list that we're given with, and also in the final linked list the ordering is the same. But what changes is the relative ordering between the left hub and the right hub, right? In the beginning linked list, left hub appears before the right hub, but in the final linked list, right hub comes before the left hub. That's what we need to do. Basically what the idea basically is, we have to just come to this node. Okay, we have to just come to this particular node, whose index will be essentially given by n minus k minus 1, right? In this case it will be 5 minus 2 minus 1. This will come out to be, obviously in this case it will come out to be 2. So we have to come at this node, and we know that we at this particular node we have to change the link, right? We have to change this link to not point to the next element, that is the beginning of the right hub elements. It will instead point to null, because this is going to be the end of our newly formed linked list, right? And also we need to store this node and this node, because this particular node, this 4, in this case this 4, this is a new head, let's call it age, and this 5 will then point to the head of the previous head of the linked list that we were given, right? So basically we will rearrange. Let's divide this linked list. We have 4, 5, and we have 1, 2, 3. Okay, basically this is the right hub, this is the left hub. Let's call the first element of the right hub as h, and let's call the right element of the right hub as tail. And and obviously the first element of the left hub is given as head in our question, because it is a head of a linked list that we're given. And let's call the last element of this left hub as I don't know, maybe tail 1, tail 1. Okay, so initially, actually in this linked list, initially it is the structure is going something like this. The tail 1 is linked to h, and obviously tail, the next of tail is null, right? This is the linked list structure, but we have to change something. We have to change, basically what we need to change is we have to make the next of tail to be the previous head of a linked list, and we have to make the next of tail 1 to be null. If we can do this, then our task is done. So let's code it. Let's code it on LeetCode itself, and where it will be more clear. Okay, just let me set my keyboard. Okay, as I said, like we have to initially take the calculate the length of the linked list. So let's say I have a current node which is initialized to head, and I traverse to car. I traverse to the linked list, and while car is not null, I increment in, and I proceed car to the next element. Okay, so now I have n. Now what I need to do is I need to take as I discussed earlier, that we have to take the mod of k with n. The reason was discussed earlier, so you can really check that out again if you want to. Now we are going to have the following pointers: h, which I will prefer to initialize as null, and tail, let's make it null. Let's initialize everything with null, and tail 1. Okay, now, and also I want to iterate obviously with the car pointer, so I again have to initialize car to head. Okay, so I again start traversing. Now in this case I have to keep an iterator, so just so I know the index of the element. So if I see that if I equals to n minus k minus 1, okay, n minus k minus 1, that means that is the last element of the left half. So what I need to do is I need to make tail 1 to be equal to car, and the element that the node after this will be will obviously the first element of the right half. So what I can do is I can do tail 1 equals to, I'm sorry, h equals to car next, because the element that will come after car will obviously be the head of the the head, I mean the first element of the right half. Okay, and otherwise and also what I needed to do in this case was like tail was going to be the last element of our of the right hub, or we can say the last element of the linked list itself in the current linked list that we are given, right? So what I can do is every time I iterate I change tail to be car. Okay, and obviously I shift car then obviously. Okay, now let's see. Now what I need to do is now is make tail next of tail 1 to be null, and next of tail to be head, and I can just return h, right? Okay, that's really it. Now there are some best cases, like if head was null, that means there was no element in the linked list itself, so we could just return null. Yeah, it's a base case, it's a simplest case. And also, if we saw that if k comes out to be 0 after like taking the mod, then then there's no point in performing the later operations, because we are not going to rotate the k by anything. So what we can just do is return the linked list itself that we're provided with, because we are not going to change it to anything. So let's see if this runs. Okay, now what did I do? um Now what seems to be the problem? Okay, so I forgot to increment I. Let's just try it out with the rest of the examples. Then we are going to, okay, let's submit it. So yeah, it's pretty much it. Now this solution is time will be obviously O of n, because we are iterating through the linked list linearly, and space will be O of 1, because we don't really use any extra space. So this is the best solution possible. So thank you guys.